before you watch this video, make sure say you don't watch the Wetin be science series where we explain wetin science be. It's very important. It's very important you watch that video to understand wetin science be before you go begin to understand physics or biology or chemistry or maths. So it's very important. Don't just jump into this one and begin to watch this video unless you have watched that series. And in case you are living in any part of Africa or the world, if you need to understand these lessons, ask a Nigerian to help you explain it. Because what I'm using to teach here is pidgin English, although I mix pure English often. I have to try as much as I can not to be doing that. I have to free myself. So, as I said before, we are now going to begin. We will now begin to teach these sciences, which we don't explain before in the Wetin be science series. This study of nature, we go now to begin to teach it one after the other. So now physics. Now physics we go start now. If you look very well for this nature tree that I made when they do the Wetin be science series, you go understand. Say I try to differentiate the different type of nature. I try to classify or group nature into different parts. So there is one part of it that I call the invisible nature, where heat, light, energy, force, gravity, time, sound. I group them one side, and I mark this as physics. Though this thing may not be very perfect, but it's just about it I explained before. So we are going to pick this side of nature where deal with invisible things. Heat, light, energy, force, gravity, time, sound, and many other things like magnetism. I didn't mention it before. Many other things. We are going to pick this side now, which fall under physics, and talk about physics. So, Wetin be? Wetin be physics? Physics na the branch of science. Now you already know what in science be. Now the branch of science, you can put study of nature here, but and I don't want to be putting it here because by now, if you follow this lesson, you should be able to know that when I say science, it means study of nature, or when I say study of nature, it means science. But for the sake of some of us that are not so fast, let me put it again. Physics is not the branch of science, a study of nature, where the wey dey deal with the study of matter in relation to energy. Physics na the branch of science which I say before many times. When I say science, just know to say na the study of nature, wey dey deal with the study of matter in relation to energy. So, as you can see, you say energy here. Matter are the things wey you can see, which we categorize under one part of nature, under the things wey you can see. So when all those things wey you can see interact with energy, let me open that our nature tree again, nature map again. When all these other things like star, water, soil, planet, animal on the biology side, even thunder, winds, when all these other things interact with this invisible thing, part of nature, physics occurs. That's the best way you can understand it. When those things you can see, like stone or rock or wind, or even the thing you can see like wind, interacts with the thing you cannot see, physics occur. Physics is a branch of science that deal with the study of matter, the thing you can see, in relation to energy, which we can for now call it the thing you can see. When the thing you can see interact with the thing you cannot see, physics happen. Like you throw up ball, you kick a ball up, it fall down. The force or energy from your foot took the ball up, it fall down. It reacted with gravity, then it fall down. Physics have happened. Or you can really say it's the study of matter in relation to energy, even motion. You can add motion here, force, although those things are all product of energy. But we're more intuitive like this. So when those part of nature you can see reacts with the ones you can see, like you can see energy, you can see motion, you can see force, but you can see matter. When those part of nature you can see react with the parts you cannot see, physics occur. Like I say, you kick a ball, you can see, then gravity bring it down. You can see gravity. Physics have occurred. So it's very important then that we discuss wetin be matter. So wetin be matter? Since physics is the study of matter in relation to energy, I don't talk am before. Matter na anything wey get weight and can occupy space. So is there anything you know that no get weight and no occupy space? So what it means is matter no anything. So you can even cut this long story short. Just say matter and anything. Really, that's the meaning of it. Because this occupy weight and space, you can get it confusing. So matter and anything you can touch. The computer or phone you're using to watch me, your Bible, your book, even yourself, your matter, car, anything you can see, including air is matter because you can feel it. Anything you can see and feel is matter. The totality of anything, whether it's the moon, whatever it is, matter. It's just like almost like we described nature before. Yes, nature is made up of matter. So all those things we have been talking about, where exists in nature before, they are all described as matter. So matter is anything. No need to give an example because if I want to give an example, I can spoil the definition. Wetin be matter? Matter and anything. Anything you can see, anything you can touch, anything will get weight and can occupy space. And everything, everything do that. So energy. Wetin be energy? Wetin be energy? Energy. Now, the ability to do work. That's it. Work doesn't necessarily mean going to go to work. Work could be anything like pushing a chair on your table or somebody throw you something. You catch it. In physics and science, that is work. The ability where you get to do work, whether you push a chair or somebody push a chair to you, it's called work in science. Now, physics make people they ask question such as one, why do airplane fly? So if you ever ask that question, why do airplane fly? You're actually asking physics question. Two, you're actually asking physics question because this is it. Why do airplane, this is it, matter, fly? This is it. Motion, energy is involved in this motion. So what you're asking is a physics question. Why do airplane, matter, fly, motion? Why do I fall down? Why do I fall down instead? Or let me say, why do things fall down instead of up? Since you were born, say if something fall, it go fall down. So why do I should say things matter? Why does it fall? energy, motion is involved in that fall. You can take it to fall down. Energy, motion is involved in energy. You can ask another question people fit ask. Why do the sole of my shoe tough? If you buy new shoe, small time you go see say the heel or the sole go begin to chop. So why is it happening? Why do the sole of my shoe, this is sole of your shoe, is matter, something you can see. Why does it eat off? That eat off is as a result of motion. When you are walking, energy is involved in pressing your shoe. Gradually it will eat off. So if you're asking this type of question, you're asking a physics question, whether you are aware of it or whether you are not aware of it. Another question where you feel ask, what could be a physics question, you feel ask, it may not even be a question. You can just see, oh, that car is running fast. Can be even exclamation you shout. What you're wondering here is actually about physics, about the physics. Why is, oh, that car is matter, something you can see, is running fast. That's energy, motion. That's motion. Energy is involved in emotion for motion to occur. So you can see clearly that physics is all about, exactly as the definition was said, the relationship of matter, the thing you can see, when it reacts with energy, those things you cannot see that exist occur in nature, which we have detailed already in the Wetin Science series. Please always refer to that if you need to. Of course, those who have followed this anyway, you shouldn't have problem with that. So I shouldn't bother about the people that have not seen that Wetin Science series. Let me just continue this lesson. Before I proceed, let me just make this thing a little bit clearer. Let me, from our definition, physics are the study of matter, the thing you can see, like they say plain in this question. This one is matter. Why do a plane fly? This motion. Why do things no matter? Could be anything, whether not your phone or whatever it is, it's a thing. Why do they fall down? Fall down as a result of gravity. So you can see it's all about the thing you can see, those things you can see in nature, like we described before. When you react with the thing you cannot see, things fall down. Why do the sole of your shoe, sole of my shoe, okay, Why do the sole of my shoes is one word? Is the thing you can say. Why does it eat off? Eat off. See, matter, reaction, produce it off. Oh, that you can say, oh, that car is matter. It's running fast. You are wondering that car is running fast. What you are trying, you are imagining the physics of it. It could be, why are you even sitting down and not falling inside under the ground? When you are asking such question about things you can see in relation to force or energy happening in relation to that or interacting with it, what you are actually wondering or asking is a physics question. I don't know whether I need to make it clearer. Do I need to write it for some of us? Airplane. I want to make this matter. There's an arrow. Fly. Energy. Sexual. Fly is actually motion, which is a product of energy. Brackets, energy. Things matter. Why do things is matter? Fall down. Silence of force is energy. Gravity. Bracket, gravity. Which we categorize under that classification. So this one make it very clear. It's a perfect example. Why do things fall down? Matter in relation to those things you can see in nature, gravity. Why do the sole of your shoe? Sole of your shoe is matter. Eating off is as a result of motion. Eating off is as a result of motion caused by motion. Eating off is caused by motion. Eating off is caused by motion. Motion, which is as a result of energy. If there was no energy, motion wouldn't occur. So ultimately it's energy you are talking about when you talk about motion. So you can, if you said that car, this still matter again. Running too fast. Again, you have motion here. Motion, which is a result of energy. to finish. That's bracket. Sorry for the handwriting. So there is no, this is why I always say science is the easier subject to understand. We are not talking about something you cannot see. Everything we have mentioned here, you can already see it for yourself. It's just for you to understand it as I have made it clear now. Matter reacts with energy. Physics occur. That's it. Things you can see react with things you cannot see. Physics occurs. I think that's the simplest definition. But the official definition is still there for you. My duty, as I have said, my goal is to help you conceptualize this, to understand it fully, so that you wear this physics, wear science. Somebody will ask you, even if you are sleeping, you answer the question. For a long time, people have been there asked all these small questions since human beings came to this world. People they wonder about these things, not just about plane and because I use this example because we they see plane, because of other things like the moon is turning, people they see with their eyes. Something is falling on its own. A tree is falling, or they throw stone, it fall. All these things were once big deal. That although we take it for granted, there was a time that people spend a lot of time just trying to understand if you throw a stone, what is really going on. No, people wonder about it. They are just wondering about nature. So people like Isaac Newton. Before I continue, this Isaac Newton I'm talking about here, it's just that Western education have imposed this kind of knowledge on us. It doesn't mean that our ancestors in Africa weren't asking this question. Of course, they asked this question even gone ahead of the West. Before Isaac Newton was born, Pythagoras studied mathematics here in Africa. Before Isaac Newton was born, before Edison was born. So once upon a time, we were already ahead of this Isaac Newton and other. So that's one of the things I say I will point out whenever I see it. So people like Isaac Newton been they ask all these small questions. People like Galileo Galilei. Is it Galileo Galilei? Something like that. People like Galileo Galilei been they ask this small question. Sorry. According to Western education, supposed to be people like Galileo Galilei be the ask that question before Isaac Newton. So the important thing to know here is that all those questions where we don't ask above, people have been wondering. They ask all those little questions. Why do things fall? Why do things fly? All those little questions. Now like that, physics they begin. Now all those small small questions physics take begin. Later people then started, you know, quantifying it from Isaac Newton time. From Isaac Newton time, people then began quantifying it. I mean, uh, people then begin, bringing mathematics into it to calculate it. You know actually that, as I said before, if you push a chair, what amount of energy did you use to push that chair? Or somebody throw you something. What amount of energy did he use to throw it to you? What is the speed the thing throw you take reach you? Or in the example we use of car running, if a car is running, what is the amount of speed it's running? What is the distance it's covering? All those stuff. Now all those little questions like that, physics they begin. So people like Isaac Newton, as I was saying before, so begin quantifying it, begin bringing mass into, begin to know the amount of value. As I said, whether something was thrown, whatever it was, they begin to have a means of understanding it mathematically. That was when physics opened up. So, Isaac Newton was a great thinker. So he came up with different laws. I mean, just he observed many things. Observed them. I don't like talking about this Newton and what is. I feel sad about this whole Western education that imposed something that shouldn't be. Because you can't tell me that it was only Isaac Newton that was thinking this. Africans was thinking this. They built the pyramids before Isaac Newton. So, but let's forget that for now. Let's just continue. Because to build this pyramid, you needed, a lot of mass, knowledge and mass and physics to do that. So certainly Africans knew all this before Europe. So Isaac Newton came up with laws that they called he observed, not as he came up. It's not Isaac Newton law. This natural law, as we already said before, that science is all about study of nature. These laws are not Isaac Newton law. They are the laws of nature. Isaac Newton came up with a law known as the law of nature. This law simply states that if something is in one place, it will continue to be in one place forever unless something make it to move. So as you can see, it happened everywhere. So really, you cannot say it is his law. It's just the law of nature that he observed. But he also observed that if something is big, it will take you more force or energy to move it. And if something is small, you will need a little amount of energy to move it. Like one bucket of water. If I tell you to bring it to me, you need big energy to bring. But if I tell you to bring me a cup of water, you just need a little energy to bring it to me. So he called that one, or rather, no, he just expressed as force. Is equal to mass times acceleration. We'll explain it later. The more the force, the more things you can do. The less the force, the least thing you can do. So he came up with another law. He said that he observed Rather, not it came up. He was just observing nature. He observed that every action reacts with opposite action. Every action reacts with opposite action. Yes, that's it. This you can say this is the law of do me, I do you. If you are pushing a wall, the wall is pushing at you. So really, that's what he's saying. Before P Square them sang this song, somebody already put it as a law. Do me, I do you. If you are pushing a wall, the wall is pushing at you. So as Newton observe all these things. For example, this force times ma. That means if you know the amount of mass something have and the speed is moving, you can know the amount of force it will use to move that thing. So as you can see, he was able to put it as a mass so that you can actually quantify, understand it in a matter of quantity. Is it 2? Is it 3? Is it 4? Is it 5? I think it will be clearer like that. Physics get many parts of it. As you can see from the I always like to refer to this diagram, our nature diagram. As you can see, the part that is light, heat, energy, force, gravity, time, sound, a lot of things. This is just few. All these examples I gave in the Wetin Be Science series. These are just few I remembered. So there are many of it. So those parts is what I want to tell you now, including the part we are studying now. The part we are studying now, like all these examples I gave, are under mechanics. Okay, let me just write it. Classification of physics. In physics. These are the ones that I can remember. Mechanics. As things moving. Like all these examples I gave. About car or airplane moving or the sole of your feet eating. It's all under mechanics. Things moving. That's simply the definition of mechanics. Then the apart you can study fluids. You already know fluids, liquids. The apart you can study parts called thermodynamics, which is the part you can study heat as our nature diagram show. They call it also thermal physics. Thermal physics. It's nothing but heat. The part that you study heat, that's what it's saying. Forget about the big grammar. Then electricity. You have another part of it where you study electromagnetism. Magnetism, which is nothing but electricity and just magnetism and electricity. 5. Waves. Waves are not optics. We could still be under those. No. Magnetism, but let's forget it. Let's put it under optics lights. But let me just make it easier to understand by making it separate. Optics. There are parts you can study light. Then there are parts you can study really very small things. Then they call it quantum, or we call it. We are now scientists, so you and me, all of us, we call it quantum physics. This one, no, really very small things. Like the thing we are studying now is under mechanics, where things are too large. It can be even what the example I gave can even be the sun, the movement of the sun, the movement of the planet, down to the movement of a ball, as I said. So all those ones are under mechanics. So I think I would like to make a diagram. All the example we gave before, again, all the example we gave before, car moving or the sole feet chopping or falling down when you throw them, they are under mechanics, which is a section of physics. There are other groups, things you can study, which I have listed below. So over time, we are going to study all of them, one after the other. Since what we are doing now, most of the thing we are doing is going to be even and on this mechanics, I like to make it a little bit clear. Mechanics. So let us pick out mechanics. Mechanics. Explanation. Explanation. Explanation of mechanics. So let me draw this little diagram for you to help you understand this mechanics. It's mainly for 4 parts. Four parts. This thing is going up on its own. So mainly 4 parts like this. As I said, one part let me right size there. SI, this SI, Z, E, size. So we can start from atom, the smallest thing. We will come to all this when we talk about other branch of science. Atom is the smallest thing you can get of anything when you split it down. So we started from smallest thing to biggest things, big things, big things. So under big things, you get classical mechanics or Newtonian physics. Classical. classical mechanics or classical physics, mechanics, or Newtonian physics. All of them is still that's it. So these small parts, when you are talking about really small things under this classical, things that are small, very small, like atom, as I said, quantum, quantum mechanics. This is just the example I have given you. I'm trying to explain to you this mechanics type of physics. I say physics have many groups. I'm trying to make it clearer for you. The part that is mechanics, what it's composed of. That mechanics itself is divided into other parts. That's what I'm trying to do. So, of things that are very small and things that are very big, like all the examples I gave, like cars, things that are very big, like cars, planets, things that are very big, like like this, like cars, airplane, even planets. They are studied under this classical. Quantum is when the things are really very tiny, and no, when the things are too small like that, this law of Isaac Newton, I mean that this observation of Isaac Newton tend to not happen exactly as Newton stated them. So there's another I would like to draw you here, and this part we are going to call this part speed. Speed. So this speed part too have what you call relativistic or mechanics. Where Albert Einstein's work was now based. So when things now are moving really very fast, from say a snail, what is the slowest thing you can think of? Is it a snail? The light. When things are moving really very fast, these laws of Newton that we said would that we stated above, those observation of Newton, as I prefer to call it, tend not to be exactly as it is when things are moving very fast. Even when those say no, so this another quantum pass. Quantum pass. Quantum field is the latest branch of physics. I mean mechanics. Quantum field mechanics. Quantum field theory. Or quantum field mechanics, I believe. So when those things are moving, things that are very small are moving at a very fast speed. They tend to have new laws that wasn't even known by about Einstein. So that's how I can explain it to you now. Classical, very big things. Let me review it again. Classical, very big things like cars, planets, airplanes moving, which is the part or the examples we give above, like why do airplanes fly? They are under this part of mechanics. Then quantum will be when we start to talk about atoms, things that are moving, that are really very small. These laws tend to change. Then when these things that are moving really very fast, categorize another speed, like from snail, when it's moving at the speed of time, light, even time can wait for you. You know, you can actually be in sync with time, and because time will actually wait for you. That's all I can explain that. Then it even get more crazier when it goes to the quantum future. A lot of things begin happening here that are even wider than what relative mechanics is talking about. So all this is parts of physics called mechanics. Everything I explain you below is part of physics called mechanics. That's the part that study things moving, whether it's a big thing or whether it's a small thing. And these are the subcategory of that mechanics. If you know somebody who need these lessons, go ahead and send it to them. I'm looking for a way to reach to people in villages, people who their parents don't have money to pay their school fees. They should be able to listen to my lessons and learn. So should you know them, go ahead and send it to them on Facebook or any way you can. Or you know somebody that can support this project or interested in this kind of things, let them contact me.